So in this first example, they're asking us for the surface area of the shaded area. And so we just have to take the square. So the area is going to be the area of the square, which is the side squared. And then we're going to minus off pi r squared, which is the area of the circle. And we can do that all in one shot if your calculator skills are good. So 4.5 squared minus pi times 1 is 17.1084. And I'll keep 4 decimal places because I am not done. But this is in square meters. So I'll put 17.11 square meters because they gave us 2 decimals. And then they wanted it in square feet. So in square feet, we have to use our conversion factor. And we'll put the meters in the bottom because we're trying to get it to cancel out. So here's our conversion factor. But keep in mind that it's not enough to do this once because a meter doesn't cancel out with a meter squared. You actually have to do it twice to make the meters cancel out. So now we have 2 meters in the bottom, and these 2 meters will cancel out with these 2 meters. And then they're going to end up with feet squared in the top. So we'll take 17.1084 and divide it by, actually I'm not going to take only 2 decimals, that's not enough, you got to keep more. Divided by 0.3048 squared, so twice. So I'm getting 184.15 feet squared. So just a reminder that when you're doing conversions with square and cubic units, you have to do it more than once. Next question. What is the surface area of a right triangular pyramid with a base length 2.5 and a slant height of 3? So when they give you the slant height, they're not giving you the pole in the center of the tent, they are giving you the zipper. So 3.0 meters here and 2.5 meters here. So that actually makes our lives a lot easier because this is what we need for the surface area, the slant height. So we're going to have a triangle with a height of 3 meters and a base of 2.5. So the area of the triangle is going to be 1/2 base times height. And then you have to also add the area of the square, which is 2.5 squared. And because there are 4 triangles around the face, you need to multiply this by 4. So if you do that in your calculator, you're going to get 21.25. But I'm just going to round it to 21.3 meters squared to 1 decimal place. What is the volume of the largest possible cone that will fit into this cube? So I'm going to draw the cone, hypothetically. It's got a base, and then it has a height, and the height of the cone is maximally the height of the cube. So this height is going to be, oh, they have to give you a height. I did have it. I just erased it. So let's just say it's 3 centimeters. Okay, so the height is also 3 centimeters on the top here. And then the radius, though, is going to be half of the diameter. So it's 3 centimeters across, but this is only going to be 1.5 centimeters. So when we do our calculation, the volume of a cone is going to be 1/3 pi r squared times the height. So we'll just plug that in. The radius is 1.5 squared, and the height is 3 centimeters. So what does that equal? 1/3. Please use the pi button. Don't use 3.14. It's not accurate enough. And I am getting 7.0686 centimeters cubed. So this is going to be, the answer to this one is going to be 7.1 centimeters cubed. So the second part, which asks you to do it in cubic inches, we're going to keep 4 decimal places when we do this. And here's our conversion factor. 1 centimeter is 0.3937 inches. And I'm putting centimeters in the bottom because I want them to cancel out. And I recognize that a centimeter does not cancel out with a centimeter cube. I have to cube both of these. So if you do that, I'll multiply by that 3.3937 cubed then I'm actually getting 0.4 inches cubed for part B. What is the volume of this composite shape in milliliters? So there's a sphere on top of a cone. The temptation is to say that because it's made of two pieces, I'm just going to add them together. So I'll take this and I'll take the cone and I'll run with it. The problem with that is that you are then double counting the volume of the bottom hemisphere. So this right here. Because this bottom hemisphere is both a piece of the cone and it's also part of the sphere, you don't want to double count it. So what you should do is you should only count the top half of the sphere. So whatever the volume of the sphere is, you're only going to take a half of it. And that's going to be the key to getting this one right. I'm not going to finish it. I just wanted to point that out. Sometimes when you have shapes that are partially inside shapes, you can't double count the volume. This question says a bailing bucket can carry 3.5 liters of water. Actually, I'm going to go back and finish this one because I want to show you something else. What is the volume in milliliters? So I'll go ahead and plug this in. So 1/2, 4/3 pi, and the radius is 4 cubed plus 1/3 pi 4 squared times 12.5. So 0.5, if you type it correctly, I'm getting 343.5 centimeters cubed. So what you're expected to know to convert this to milliliters is that 1 centimeter cubed is equal to 1 milliliter. So this, you could literally just change this to say milliliters. If you wanted it in liters, you'd have to divide it by 1,000. So in liters, it would be 0.344 liters. But they asked for it in milliliters, and so you have to understand that a centimeter cubed is 1 milliliter. And that's going to be relevant for this question. So this says that a bailing bucket can carry 3.5 liters of water, but how many buckets will it take to fill this cylinder? So first we need to find the volume of the cylinder, which is the area of the base times the height, which is pi times 1.3 squared times 2. So pi times 1.3 squared times 2 is 10.6186 meters squared. So what you got to ask yourself, is it true? Like I understand that 1 milliliter is equal to 1 centimeter cubed, but is it true that 1 liter is equal to 1 meter cubed? Because that's a temptation. And the answer is no, that's not true at all. Okay, so this is the conversion we have. We do not have this conversion. We can't just convert it into liters easily like that. So here's the plan. We are going to take our meter squared that we have. We're going to go into or it's not meter squared, it's meters cubed because it's a volume. Meters cubed, we're going to take it into centimeters cubed. We're going to take the centimeters cubed into milliliters. We are going to take the milliliters into liters. And then we are going to take the liters into buckets because that's what our final answer is going to be. So let me show you this. It'll be the original amount we have, meters cubed. And then we got to go into centimeters cubed. So there are 100 centimeters in a meter. But you got to do that 3 times because it's a cubic unit. And then, with the centimeters cubed in the top, you have to understand that there's 1 centimeter cubed in 1 milliliter. Let's just check our units and see what's canceling out. Oh, I can already see that I've done this wrong. I flipped this because I need to put the meters in the bottom, otherwise it doesn't cancel. It's a good thing I checked that. So 1 meter is 100 centimeters. I did that incorrectly. So I should really cancel my unit as I go. These will cancel because this is cubed actually. And then let's see. A centimeter is a milliliter. So then those will cancel. And then I'm going to say milliliters. There's 1,000 milliliters in a liter, and you should know that. And those cancel. And finally, buckets. There are 3.5 liters in a bucket. So the liters cancel. And notice how all my units have canceled out except for my final unit, which is buckets. And that's good. That's what I want. So now I just have to punch it in correctly. So the original amount times 100 to the power of 3, and then divide by 1,000, divided by 3.5. And I'm getting 3,033.9 buckets. So I guess you could round that to 3,034 buckets in order to make this happen.